Before the task class was introduced, the thread class was the easiest way to add threading to C# code. While the thread class has been superseded by the task class, you're still likely to see it being used in older projects. To begin this lesson, open the Mathland project from your sample files folder. And open the code behind file of primes.aspx if it isn't open already. Now remove all of the existing threading code. That's everything from action object to thread2.wait. Next, you're going to add some code to create a new thread using the thread class. First, add the following using line to the top of the code. Using system.threading. The thread class is in the system.threading namespace, so this line will make it easier to access. Now in the button Calculate Primes click event handler, add the following code after the line that begins int maximum value. Thread1 equals new thread, new parameterized thread start, calculate primes. This code creates a new thread object that will run the calculate primes method. You need to use the parameterized thread start object in order for the thread class to run a method that has arguments. If the calculate primes method didn't have any arguments, you could simply use the code thread1 equals new thread calculate primes. Now add the following code on the next line. Thread1 dot start new int 2 maximum value divided by 2. This code tells the new thread to start running. Because you only want thread 1 to do half of the work, you are telling it to calculate prime numbers from 2 to half of the maximum value. Next, you'll need to add some code to create a second thread. Add the following code on the next line. Thread2 equals new thread, new parameterized thread start, calculate primes, thread2 dot start, new int, maximum value divided by 2 plus 1, maximum value. This code creates and starts a second thread, which will calculate the other half of the prime numbers. This code is vulnerable to race conditions, in the same way as you saw in Lesson 3.5. Unfortunately, the thread class doesn't offer a convenient wait method, so the code to prevent a race condition is a little more complicated. Add the following code on the next line. While thread1 dot is alive or thread2 dot is alive, thread dot sleep 1000. This while loop will cycle as long as the thread1 and thread2 objects are both alive. That is, as long as they are both still running their calculations. Thread.sleep tells your application's main thread to wait for a number of milliseconds before continuing. Without the thread.sleep line, this while loop would cycle as fast as your computer could manage, which would be a waste of your computer's processing capacity. Because of this line of code, the while loop will check whether the threads have finished once every second. Let's test your code now. View primes.aspx in your web browser and click Calculate Primes. This time, the calculation finished in 19 seconds. This is not quite as fast as the task class, which managed to finish the calculations in just 18 seconds. While the speed difference isn't very large, this illustrates the performance improvements that are offered by the task class. Close your web browser now and close Visual Studio. You've now completed Lesson 3.6. Implement multithreading using the Thread class.